This is Mr. Murray coming to you from the set of Das Boot. If you're wondering what the subsonic rumbling is in the background, I don't know what it is either. Let's go through this formative assessment 3.2 here. We've got a ball rolling off the edge of a 15-meter tall cliff, right? So we've got the, let's draw a little picture here. Oops. There we go. Right? And it lands at 12.4 meters from the base, right? It's 15 meters tall and must follow some trajectory like this, right? Like that, right? And we want to know what time is it in the air, what's its horizontal velocity, and its final vertical velocity just before it hits the ground, right? So let's fill this thing in. This is projectile motion, right? All projectile motion problems have no horizontal acceleration and a vertical acceleration of gravity, right? Negative 9.8, right? Since the cliff is 15 meters tall, we say the ball starts at the top and goes down, so it's actually going to displace itself down 15 meters. Right? So if they tell you the height of the cliff, you're going to say that for the displacement there, it's going to go down that distance, right? Okay. Now, since it's a cliff problem, and since it says it's a purely horizontal velocity like that, right, then you're going to say the initial vertical velocity is 0. Okay. Now that gives us three things here. We've got the displacement, the initial velocity, the acceleration, right? And then horizontally, this 12.4 meters it is from the base of the cliff, that's going to be our horizontal displacement. So that's 12.4. Okay. Now when you set this thing up, these guys are always the same. Okay. So there really are only this, this, and this. And all we ever do in the horizontal side is V, X, and T, these little triangle problems here, right? Okay. There really are just three players there, right? This is full-fledged, we're going to use all of our kinematic formulas here. And whenever you know three of these things, we can solve it. So this is 1, 2, and 3. We know these things, right? So we can solve this thing. In this case, I'm going to find my final vertical velocity using no t. So I'm going to go Vf squared is Vi squared plus 2ax. So the final velocity, the absolute value of that would be, square root of 0 squared plus 2 times negative 9.8. And notice when I'm doing my math here, I use only values from this side. Okay, and then negative 15. And here's where, if we didn't make that negative, we'd have a negative number under the radical, which wouldn't fly. So let's see, let's try this. I'm going to go square root. Left parenthesis, you have to do that on my calculator, right? I'm not going to type the 0 squared because I know what it is. So 2 times negative 9.8 times negative 15. When I do that, I get 17.146. So I'll say 17.15 meters per second, right? But think about this, right? When it hits the ground, it's got to be going down, right? This is the absolute value of the final velocity. As we took the square root of a square, we don't know whether it could be plus or minus, right? Definitely, though, when it hits the ground, it's going down 17.15 or whatever. It's really 146 or something like that, right? Okay, meters per second. Okay, so we've got the final vertical velocity. That's one of the questions, right? That was the first thing we solved for. Go figure, right? Okay, so now I want to figure out the time it takes to hit the ground. So to figure out time, I'm going to use, and there's lots of things we could do. Since we have the final vertical velocity, we could use Vf is Vi plus At, right? So negative 17.146. Notice I'm not using the rounded version. I'm going to use the version on my calculator, right? That equals 0 plus negative 9.8 times t. This works, right? So divide that by 9.8. I got 1.7496. Okay, and that's just time. Whoops, there we go, right? A little spacey here, so 1.7496, right? That's one way to do it. The other way to do it is to use 1/2 at squared, right? X is 1/2 at squared, which is of course our fancy formula, VIT plus 1/2 at squared, but our VI is 0, right? So it's always this. And so for that guy, we would have negative 15 is 1/2 negative 9.8 t squared, right? And now when we do our math, we got to be careful, right? I'm going to take this. I'm going to go 2 times negative 15 over negative 9.8, right? And that's going to be t squared. So let me do that. 2 times negative 15 divided by negative 9.8. And that's 3.06. And I'm going to square root that. So I'm going to go second square root, second answer. And I get 1.7496, right? So it doesn't matter which way you do it. This way is morally pure because I didn't use my final velocity, which could have been wrong, but I should have more confidence in that, right? So now I put the t over there, 1.7496 seconds, right? And now we've got the terrible task of figuring out this horizontal velocity, right? Okay, so this guy right here is just going to be this divided by this. So we want oh, that's not the right triangle. Let's write the right triangle. X, V, T. There we go. That's the right triangle. Okay, so we want V. V is X over T, right? Where do I have any room anywhere? I don't have any room anywhere, so I'm just going to write it right here. So 12.4 over 1.7496. So I'm just dividing this by this, right? 12.4 divided by the answer. Is 7.087. Okay, so let's see if we've answered these questions. What time is the ball in the air? 1.75 seconds. Yeah, that would round to 1.75 seconds, right? Okay, what is the ball's horizontal velocity? There it is, right? 7.087 would be both of these, so 7.09, right? We got that, we got this. Right, what is its final vertical velocity? Well, 17.146 would be roughly negative 17.1. Don't forget the minus because it's going down, right? You got to put the minus on there. You want to get all the points there, right? Okay, and then in the next part of the problem, we're going to use this. These two numbers, okay, the 17.146. And the 7.087. Okay, so just hang on to that notion there. All right, so now we want to draw a velocity, right? And when you look at this, this was 7.087. This guy was the final velocity, right? Right, this guy was 17.146. And this guy was 0, right? This is negative 9.8. This was, et cetera, et cetera. All we care about, though, for this is this, right? We don't care about the height of the cliff. We don't care how far out it went, right? We care about this. So this is what we have to draw a picture of. So let's draw a picture. There it is there, right? Here's this guy. And then here's the actual velocity right there. Okay, so you're going to draw a nice little picture like that. That's 7.087. This is 17.146, right? And this is these are meters per second. Okay, and let's find the angle there, right? So that angle there is inverse tangent of opposite over adjacent, right? So tan minus 1 of 17.146 divided by 7.087. Okay, so I'm going to take my calculator, I go second tan. I have to type a left parenthesis, 17.146. You might have it already pre-typed for you, divided by 0.087. And that's 67.5 degrees. Right, and then the magnitude here, this thing is the magnitude, right? It's also the speed. It's also the hypotenuse, right? So we'll find that speed by going square root of 7.087 squared. Plus 17.146 squared. So here we go. I'm going to go square root of, left parenthesis, 7.087 squared plus 17.146 squared. And I get, wow, what did I just do? I just typed times. Okay, hold on. Let's actually do that. I get 18.6 meters per second, roughly. It's 18.55 or something like that, right? So you would say that this thing hits with a speed of 18.6 meters per second. If it was just, we didn't care about the direction. If it was a scalar is what we call that, right? If it's a vector, we would say 18.6 meters per second at 67.5 degrees below the horizontal. All right, so this is the picture you need to draw. Make sure you've got arrows, right, that you go to the right and down, that you draw a picture of that, that you label which angle you're finding. I would always find that angle. Label the hypotenuse with its length. You should be set. That's what we do. All righty.